Hello everyone, thank you for joining us for today's webinar. My name is Neil Foley and I'm the Applications Engineer here at RIZE. Today I'm going to be talking about some of the applications of full color 3D printing in manufacturing. So we'll get started. So first I wanted to talk a little bit about the general utility of color and why being able to apply color to 3D printed parts can generally be useful. So some of the values of color include the fact that it makes parts rapidly and reliably recognizable. So what I mean by this is that if you have a set of parts that are all the same color, for example, if you have a set of parts that are the same color, but each of them has a different serial number or a different iteration number, then it can be time consuming to sort through them and find the specific iteration or serial number that you're looking for. However, if you print parts using color, not even necessarily color over the entire part, but even just tags of color, then that can allow you to very quickly identify a single part from among the rest just based on that small tag of color. So the idea here is that you are able to visually communicate a variety of different information by applying color to parts. So this can include information about the part's metadata, as I mentioned, serial numbers, iteration numbers, maybe even differences in what printer or what location a part was produced at. It allows you to instantly distinguish among differently colored areas or components. So this could be for parts that have a variety of different inputs and outputs, and in order to properly correlate them, you could once again use standard markups, perhaps putting letters or numbers at each of those inputs and outputs, but it can often be much more time efficient to simply color each of those using corresponding color codes, and that allows you to just with a quick glance identify which parts go together. And finally, the last point I have here is the fact that using color on parts naturally leverages existing knowledge. So examples of this include green can mean yes and red can mean go. Everyone understands that, and a single color can often be used for multiple purposes along different dimensions. So red is also useful for identifying high heat or various other kinds of danger. So now I wanted to, if I can get to the right slide, I just wanted to talk a bit about what RIZE does in order to accomplish the production of full color 3D printing. So RIZE uses a hybrid process that we call augmented polymer deposition, where we combine a plastic filament extrusion nozzle with the type of ink heads you would find in a 2D printer. And what we do with these is we extrude thermoplastic through the nozzle to build the bottom layers of a part or a build. On top of that, we'll jet different types of functional ink, and then we'll add additional layers of thermoplastic on top of that. And we're able to alternate thermoplastic and then ink for each layer. Now, we're able to use a variety of different functional inks between these layers. Those include the two shown here. There's marking ink, which can come in a variety of different colors to achieve a full spectrum of markings. And there's also release ink, which we jet between support and model structures in order to make the post-processing of our parts very quick and easy. So generally speaking, there are several different major categories of applications of full color 3D printing. They're useful in engineering situations for visualizing and communicating various information. One particularly common use of this is FEA simulations, where you can demonstrate using heat maps the stresses or displacements that result from a load case on a part. There's also package design prototyping, where full color 3D printing allows you to faithfully recreate a full color model in the shape and pattern that you wish to eventually manufacture it. It's also useful for GIS map visualization, which is valuable in surveying and military and architectural applications. It's also valuable to architectural design in the more precise case of modeling out specific architectural structures. And finally, it's good for producing fully colored model or mock-ups, often scaled down from what the final product is intended to look like. So on the other hand, there are a variety of different applications that are also useful in manufacturing. So some of the ones that I have listed here include using color-coded panels and notices that are fully 3D printed. They're also useful for augmenting or making more efficient the design to manufacturing handoff. They're useful for producing a variety of custom color-coded tools. And it's also useful for producing visual aids for tracking machine tolerances, which is useful in a small set of very valuable use cases. So I'll start by discussing some of the custom color-coded tools that full color 3D printing can be useful for producing. One of these is the go no-go gauge with handles. So this is a sort of mounted part that is able to hold 2 pins on each side of it, and one of those pins is intended to succeed when passed through a hole, and the other is intended to fail or be too large to pass through the hole. So these pins will have very slight differences in their diameter, and they'll often be used over and over on manufactured parts that need to have their hole diameters tested. So these can be rather expensive, particularly if you are buying a large number of them. So one of the values of full color 3D printing is that you could produce the handles of these parts with a thermoplastic printer like the RIZE, and buy the pins separately and insert them, and be able to save quite a bit of money on all of the handles that would need to have been purchased. So the value of using full color in this case is that by ensuring that one side will be green and one side will be red, it's easy to keep track of which side is the go side of the gauge and which side is the no-go. And so rather than having to check a number or a label repeatedly as you perform the quality testing process, you are able to very rapidly identify which is the correct side and check the parts much faster than if you did not have that. In addition to increasing the speed, it also reduces the chances of mistakes because you're so easily able to identify which of the 2 sides is the go and which is the no-go. So another application of custom color-coded tools is producing fixtures that have been color-coded based on some component of their metadata. This is something I alluded to earlier, where by color-coding iterations of the same part differently, or color-coding slightly different versions of a part that are used in slightly different uses, you can store the parts together or have them close to each other and be able to immediately recognize which of the parts is which version and which iteration. So this allows you to instantly locate the part that you desire from among similar parts, and it can also allow you to identify obsoleted components that need to be replaced. Perhaps if you've attached a fixture to an assembly and it's been there for 1 or more iteration cycles, then there won't be any ambiguity about it. You'll instantly recognize it just based on the color that it needs to be changed. So here's a different major application of full color 3D printing in manufacturing. It's valuable to use color coding on panels and notices, especially for safety purposes, because many companies will use yellow, orange, or red to identify safety concerns in their machinery. So the value of printing these with a thermoplastic full color 3D printer is that they're going to be much more durable than paper. In the case of Rizium, they'll also be chemically resistant, which is valuable in certain environments. They'll also be much less costly than trying to produce these in sheet metal and applying the color to it. And because they are less costly, they can be very quickly iterated and replaced with a reprint if necessary. So I'll move on now to another interesting application. So I've called this visual aids for tracking machining tolerances. And this would be a part that could be provided to manufacturers who need to perform reworking either on a part that's failed quality assurance or a part that has been cast and needs to have additional material removed. So one of the values of full color is being able to illustrate the different classifications of surfaces on a single part. So by providing a visual aid that's been 3D printed of a given cast part, we'll say, along with the cast parts themselves, it's very easy for the manufacturers to identify which regions can be machined and how much. And including this visual aid can reduce the chance that such machining might remove material from a location that it can't be removed from, or other mistakes like that. The other value of providing a 3D printed part for this purpose, as opposed to, for example, providing drawings or a 3D colored file, is that often the designers or various stages of manufacturing will be using different sets of software to process files, and they may not have access to compatible software. And for that reason, using a 3D printed part is going to be a universal way of communicating, and you don't need to deal with such complications or miscommunications from software incompatibilities. Another major value of full color 3D printing to manufacturing is the design to manufacturing handoff. And this has some similarities to the previous use case, where one of its major values is being able to prevent complications or miscommunications from software incompatibilities. In this case, it's also valuable to have a 3D printed part included, simply because a lot of times it can be difficult to interpret a part just based on a 2D drawing, or in some cases even from rotating it in 3D on a screen. So the idea of this application would be that when a designer provides manufacturers with the drawing to machine a given part, they could also provide a color-coded 3D printed guide, which would highlight the key dimensions and data associated with that part in color. And by providing a haptic and rotatable 3D part alongside the drawing, it would allow such manufacturers to remedy ambiguities in drawings and also reduce misinterpretations that could require iterations of the drawings or reworking or completely restarting manufacturing of the part. So this could eliminate a huge number of issues in the design to manufacturing handoff, and because of that, it's a great value that can be offered by full color 3D printing. At this point, I just wanted to take a few minutes to look at a part in SolidWorks and go over a little bit about how you might produce the type of color-coded part that was shown on the slide we just looked at. So this is a part that's part of a V-clamp that would be useful for holding pipes. It's also sort of a generalized design, so it could be useful for various other things. And in order to manufacture this part, there are going to be perhaps several steps in the process. And one of the things you could do is supply this part color-coded and 3D printed for the manufacturers during the design to manufacturing handoff. So I just wanted to go over a little bit of what it takes to color such a part based on surfaces that need to be properly differentiated. So in SolidWorks, all you have to do to get to the pane where you would color surfaces is go over to this colored circle sphere right here. And if you right click, it'll allow you to add an appearance. And now the default is to have selected the entire part. So if I were to select a different color, it may color the entire part, and that's not what I'm looking for. So I'm going to remove that. And then we can look at just individual faces. So let's say, for example, that I wanted to identify these faces here based on some component of their manufacturing, whether it be the tolerance of the dimensions or the step in the process. Adding a color to these parts will very clearly separate it from the rest, and when it's 3D printed, the manufacturer can easily view these portions of the part and recognize what they correspond to. So I'll give them a more contrasting color, and that's all it takes for that. And if I wanted to add a few more, I would just create another appearance and select a few more surfaces. Give it a new color, maybe this one. It's good. Now for SolidWorks, in order to save color information that's been applied to a part, in order to save appearances, that is, you can save both solid colors and images onto a part. However, there are some specific things you need to be aware of. In order to save a part like this as a color model that can be read by 3D printing software like the one-touch software produced by RIZE, you need to select the proper file type. So in this case, I'm going to recommend 3MF. Other file types that can be opened by RIZE software include STL and WRL, but only 3MF will preserve the color information that you apply using appearances. So select 3MF, and then what you'll need to do the first time is open the options menu and make sure that this box right here, include appearances, is checked off. That will make sure that any colors or images that you apply to faces will be included in the 3MF file. And now I can just save this, and it's ready to open. All right, so that's all I have for you today. I'm going to stick around for a couple minutes to answer any questions that you may have. If you do have a question, please just type it into the chat window on your GoToMeeting panel, and I'll stick around for 2 or 3 minutes to answer any of those questions. Other than that, thank you all again for joining us, and if you don't stick around for questions, please have a nice day.